know whether or not it was a positive or negative impact.
Exposing components to the environment is one kind of testing. The other testing is where we look really closely at the microstructure of materials. I think the big distinction now is the capability we have to do that testing internally and the expertise we have.
The range of capabilities that are here, I think, is world class. We're burning gas in engine dynamometers across the hall. Next to them, we've got full vehicle simulators and electrodynamic shakers.
Maybe it's a force test. It could be a corrosion chamber in our materials lab. It could be an assembly simulation in our vehicle build area. There are all kinds of different things that get simulated.
And the things we're working on now is to say, how can we do that testing virtually? So if we can measure the loads and if we can create the geometry in the computer, we can then interface those two and now exercise that design electronically. And what would take us days, now we can do in minutes.
So we're getting to a point that we understand what the motorcycles are going to experience before we ever build one. And we can understand what the limits to performance are going to be and then create designs within those limits from the very beginning.
Testing has always been a critical part of developing Harley-Davidson motorcycles and getting them to the market. In the 1920s, we know that they had a very aggressive testing program. In the late 1940s and early 1950s, one of the things Harley-Davidson was doing was getting ready to come out with new engines. When you develop all these new engines, there has to be a lot of testing done. So we know in the 1960s, road testing continued just as it had been started in the earliest days of the company. Road